Okay, so now let's look at how we can solve a system of equation using linear combination. And linear combination is what it sounds like. We're just going to combine, and by that I mean add, two equations. So what we know is that we can, as long as we do the same thing to both sides of the equations, provided it's a reasonable operation, the equation stays true. So imagine if I have a equals b, I can add c to both sides. Then I have a plus c equals b plus c. And I could multiply both sides by some number d. And the equation is still true as long as I'm doing the same thing to both sides. And I could divide everything by f. In this case, provided that f is not equal to 0. And the equation stays true. So we're going to use this idea that we can operate on equations to solve systems of equations. So imagine here we've got this system of equation now, which we've looked at in different ways before. And what we could do is we could say, well, I've got one equation here, and then this other equation below. And the equation below, I know that the left-hand side equals the right-hand side. So I can just, as long as I'm adding, like I could add y to both sides. So on the left-hand side, I'd have y plus y, which is 2y. And on the left-hand side, I'm going to add 2x plus 3 to y. But I know that y equals negative x plus 6. So I'm just going to add 2x plus 3 plus this equation. And when I do that, 2x minus x, I get x plus 9. So I can add equations like that because I'm adding y and I'm adding the equivalent of y, which is negative x plus 6. So to both the right-hand side and the left-hand side, I added the same equivalent amount. Now this wasn't very helpful because now it just gives me a brand new equation. But instead, let's consider what would happen if I didn't add them, but I subtracted them. So essentially what I'm doing is I'm taking two equations and I'm just adding the equations together because the left-hand sides are equal and the right-hand sides are equal. And the reason why I'm going to subtract here is because when I do, it's going to get rid of a variable. The other name for this method is called elimination, because when I combine the equations, I'm going to eliminate a variable. So I have y minus y, which is 0, and then I have 2x minus minus x, which turns into a plus, so 3x, and then I have 3 minus 6, which is minus 3. And then I can solve this to get that 3x equals 3, or x equals 1. So that's my x value. And then I can just take that and plug it back into my equation to get my y value. So y would equal 2 times 1 plus 3, which is 5. So my final solution would be 1 comma 5. Again, the key idea here is that I'm adding the same thing or the same equivalent thing to both sides of an equation, but in doing so I'm going to eliminate one of my variables. Let's look at one more example. Okay, so in this case, the first step that I'm going to need to do is get my equation lined up right so that I have all the variables on the same side. So I'm going to subtract 5x from both sides. And when I do that, I have negative 5x plus y equals negative 2, and x plus 2y equals 7. Okay, so what you'll see is that if I added or subtracted these equations, I'm not going to be able to eliminate one of the variables. I need to have the same coefficients for either the x's or the y's, so that something will cancel out. So let's think. If I want this to cancel out when I add it, all I need to do is multiply this bottom equation by 5. Well, if I do that, I'm going to have, so let's go over here. My top equation is going to stay the same. We have negative 5x plus y equals negative 2. And then my bottom equation, I'm multiplying everything by 5. So I'm going to have 5x plus 10y, again I'm just distributing that 5, equals 35. Okay, since I have a negative 5x here and a 5x there, I'm going to want to add these equations so that the x's go away. When I do that, I get 0 x's, so I've eliminated the x's, plus 11y equals 33. So if I divide by 11, I get that y equals 3. So now to find x, we just plug it into one of these equations. Either one will work. So I get that x plus 2 times 3 equals 7. So I can subtract 6, and I get that x equals 1. So my solution is the point 1 comma 3. All right, 2 more examples. So what about this case? Now this is the harder type of problem because there's no quick solution. So let's say that I want to eliminate the y's. What can I multiply 1 or 2 equations by? Well, if I multiply by the other's coefficient, so in other words, I want to get rid of the y, so I'm going to multiply by the top equation by 3 because I have a 3 here. And I'm going to multiply the bottom equation by 4 because of the 4 here. What that will guarantee is that I'm going to have the same coefficient in y when I do the multiplication. Let's see that work out. So when I take the top equation, I'm going to distribute the 3 across, and I get 9x plus 12y equals 30. And down below, when I distribute that 4, I have 8x plus 12y. Oh, okay, good. So I have the same 12 and 12 equals 28. So now since I have positive 12y and positive 12y, I'm going to need to subtract. And I get here x equals 2. That worked out nice. And so then I figure out what y is, plug it into any one of the equations. So when I do that, I'm going to get that 2 times 2 plus 3y equals 7, or 3y equals 3, y equals 1, and so my final solution is the point 2 comma 1. Okay, one more example. This is a sample problem. So it says I buy a Gatorade and 2 Cliff Bars for $5.50, and you buy 2 Gatorades and 3 Cliff Bars for $9. How much is a Cliff Bar? So let's define some variables. Let's say that G is cost for Gatorade, and C equals cost of Cliff Bar. So we know that from the first scenario, I buy 1 Gatorade for a cost of G dollars, plus 2 Cliff Bars for a cost of C dollars, and it equals $5.50. And in my second scenario, I buy 2 Gatorades for the cost of G Gatorades, or G dollars, and I buy 3 Cliff Bars for the cost of C, and that equals 9. Okay, well, what's the easiest way to solve this system of equation using linear combination? Well, I think the easiest way is just to take my top equation, and we're going to take the top equation and multiply it by 2. I'm going to write it right down there. Because when I do that, and I distribute the 2 across, I'm going to get 2 times 1g, so I'm going to get 2g plus 2 times 2c, so 4c equals 2 times 550, which is 11. And so now, here's my new system, and since both 2's are positive, I'm going to subtract. So subtract, 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 and I get that negative c equals negative 2, or in other words, the cost of a Clif Bar equals 2. And that's all I need to do, because that's what it's asking for. How much is a Clif Bar? So a Clif Bar is $2.